Hi everyone. Alright, I was gonna go to bed, but I have a burst of energy that I need to deal with. And so I decided to have another session. So what I want to do today, or in this session, is I would like to first use my phone. I would like to disconnect my phone. I was watching briefly the last live stream that I did like a few minutes ago. And I hammered over the point over and over. I apologize for repeating myself over and over and over. Um, Sometimes I do that, or most of the time. So my bad. Whoever's gonna watch that hour. I think at some point I was like, "Oh, for fuck's sake, move on from that point, please. I get it. Move on." But yeah, sometimes I do that. Anyways. What I want to do now is talk about we have an issue in our code where our movement speed is tied to our frame rate, meaning the faster we render things on the screen, the faster our movement is going to be. So think about it for a second. Essentially what I'm doing here is I am saying, well, the first thing you need to figure out first, that's really important, is what's my frame rate, what my frame rate is. Now I can do that if I go here to type Fraps. Fraps is an extremely old software. It's not supported anymore, but I use it. It's good enough to just show a frame rate for DirectX and OpenGL games. So it's good enough for now. So I'd like to show out my frame rate, please. That would be nice. So Fraps. Okay, the first thing you need to figure out was what my frame rate is. So if I play my game. Okay, my frame rate currently is at 12,000 frames. All right, and notice here, if I shoot bullets, my frame rate is gonna tank. It's gonna go to 300, 200, and see, the more bullets I have, the slower my frame rate is, or the slower my bullets are. Notice this is really important. If I go here, right, and my frame rate is high, I'm running at 12,000, and if I move, I move fast, like super fast. Okay, I'm gonna shoot some bullets. Notice at the very start the bullets are gonna be fast, then I'm gonna slow down. So see how fast they are, and then more bullets, the slower it is. That's because the faster my loop runs, the more like the more or the faster my bullets move, right? So I'm basically moving my bullets, right? I'm moving my bullets in a certain direction, and so the faster the loop runs, the more I'm gonna execute this code. The more I execute this code, the faster the bullets are they're gonna move. The slower my frame rate is, the slower the less I execute this code, and the less I execute this code means the slower my bullets are. And this is really bad because you don't want your game or movement speed to be tied to your frame rate. You want those two things to be completely independent. Now, I can solve this problem, right, by turning on, there are three ways I can solve this problem. I can turn on Vsync, and we talked about Vsync before. Somewhere over here. Right here. We talked about Vsync, and we said that Vsync essentially is when you turn on Vsync, you are limiting the frame rate to the refresh rate of your monitor. So if your monitor refreshes every 60 seconds, if your monitor refreshes 60 times in 1 second, that means that you're only gonna render 60 frames, and we lock our frame rate, and we can do that. Right? So for example, the way I do that is by saying window dot set vertical sync enabled to true. And so when I do that, you'll see that my frame rate is now locked to 60 because my monitor refresh is 60. That means that my movement speed essentially is much slower, right? Which is good. I mean, at least it's constant. But the problem is, if we go below 60 frames, we're gonna essentially have the same problem. Our movement speed is still tied to our frame rate. So if we go below 60, our movement speed is gonna be much slower. So that's kind of a band-aid, but not a good solution. Okay, so what we essentially need to do is not have our frame rate and movement speed not tied with each other. Now, the way I can do that is by figuring out something called delta time. And so I already explained here. Let me find the space. I already explained here that if this is my loop, and I say move, right? I say move 1 unit. Okay, so I'm moving a single unit. Let's say this runs 60 times in 1 second. So that means in 1 second, I am going to move 60 units because this runs 60 times in 1 second. I'm going to move 60 units or 60 pixels or whatever you want to call it, right? What if this runs at 1,000 times in 1 second? That means I'm going to move 1,000 units in 1 second, right? So the more this executes, the faster the movement speed. And so if I execute this as 1 time per second, which means I moved this loop happened only once. So now that means I moved only 1 unit, right? That's not good. That is not good at all. So what I should do, the solution to that is have something called delta time. And delta time is basically the amount, it measures the amount of time a single frame is being rendered. How long one frame is taking to render. Okay, so here's the thing. Usually our move code looks like something like this. Position plus equal direction multiplied by speed, by a certain speed, multiplied by time dot delta, or by just delta time, to delta time. Okay, if I forget multiplying by delta time, let's assume this does not exist. What happens is the same thing. If this operation runs 60 times, I'm going to move in a certain direction with a certain speed 60 times, right? Or 60 units. Let's assume my speed is 1 and my direction is 1, 0. So I'm moving to the right. Multiply these two. 1 by 1 is 1. 1 by 0 is 0, right? And so this is executing 1 time, so I only move 1 pixel every second, right? Which is not great. Now, here is the thing. Delta time is, so this is a constant. This is a constant. My speed is constant, that doesn't change. My direction is constant, doesn't change. However, delta time is a variable, as in it it increases and decreases depending on the frame rate. So delta time is the measure of how long a single frame is taking to render, right? And so if it's taking a long time to render a frame, let's say 60, it's taking 60 milliseconds to render a single frame, right? So now I all of a sudden multiply by 60. Okay, where before we didn't multiply by delta time, we just said 1.0 by 1 equal 1.0, right? This is the direction I'm moving and the rate of speed I'm moving 1 unit to the right every frame. However, if my frame rate is low, like my frame rate is extremely low, this number will be high. So if my frame rate is, let's say, I'm rendering 2 frames per second, so I have 2 FPS. That means I have 60 milliseconds, assuming I have 60 milliseconds for my delta time, because the lower my frame rate is, the longer it takes to render a single frame. And so let's assume 60 millisecond. So now I do 1.0 by 1 by 60. 60 by 1 is 60, right? So now in a single frame, rather than moving a single unit, I moved 60. I moved 60 units to the right. Okay. Now let's assume my frame, so that's if my frame rate is low. So you can see now my movement speed has increased when my frame rate dropped. Now let's assume my frame rate increased, right? I'm running my game on a good system, and now I'm running at 30 ms. 30 ms is still not good, but let's say I'm doing that, right? So now this loop runs more often. This loop now runs twice as fast, so 2 times a second. So now I have 1 multiplied by 1 multiplied by 30. Okay, so now I have, this is 30, so now this is 30 comma 0, this is 60 comma 0, right? This was happening when my frame rate was at 60, or when it took 60 milliseconds to render my frame rate. And that means 1 per second. 1 FPS per sec. Okay? Now, my frame rate increased. My frame rate is now 30 ms. It's taking it's taking 30 milliseconds. It is taking 30 milliseconds to render 1 frame, which means now I'm running at 2 FPS per second, right? So that means in 1 second, notice now, in 1 second, I have moved the same amount of distance. One frame rate per second, I moved 60 units. In 2 frames, I moved 30 units. So 30 multiplied, in a single frame. In a single frame, I moved 30, right? So 30, you need to multiply it by 2, and you get 60. So essentially what's happening here is that I am moving the same distance no matter what my frame rate is. If my frame rate is 1, right, then I'm moving 60 units. If my frame rate is 2, I'm still moving 60 units, because delta time goes up and down depending on my frame rate. All right. That's kind of the idea of time, that that's the kind of the idea of delta time, is that I move the same distance, I move in the same rate, no matter what my frame rate is, because delta time is a variable number. It goes up and down with my frames. All right. So that's literally the entire idea. I want to go over this a little bit. One more. I feel like I didn't explain it too well. So apologies about that. You can just skip this part if you understood it. But here I'm moving, this is my direction. I'm moving 1 unit to the right, multiplying it by speed, which is 1. right? Multiplying it by 60, right? Because 60 by 1. Okay, let's start this over. I just want to start this over. My delta time is 60 ms, right? I'm running at 60 ms. It takes 60 milliseconds to render one frame. Okay, so if I have direction multiplied by speed by delta time, this multiplied by this multiplied by this. Now 60 multiplied by 1 is 60, which means over here I'm multiplying by 60, right? Because 1 by 60, speed by delta time 60. So 60 multiplied by my direction, I'm now moving 60, 0. And this is happening once per frame. I am moving 60 units per single frame. Okay. Now, the next option is that now my frame rate increased, right? I am now running at 2 FPS. When my frame rate increases, my delta time decreases. So I'm running at 30 milliseconds. So 1 multiplied by direction multiplied by speed by my delta time, 30 by 1. This is 30, and this is my direction. So now I'm moving 30, 0, right? 30, 0. So that means I'm moving 30 units every single frame. How many frames do I have? I have 2 frames. So my loop executes twice in that 1 second. So now I need to multiply how much I moved, my direction, 30 by 2, which is 60. So I essentially moved the same amount of distance between, no matter whether my frame rate is at 1 FPS or 2 FPS, whether my delta time was 60 or 30, I moved the same distance because delta time increases and decreases depending on my frame rate. All right, so now that I covered that, I feel like I'm a little bit more satisfied with that explanation. What I can do now is execute it. How do I execute it? Well, the first thing I need to do is, so this is my fraps. I need to keep it open for a second. Just verify that I unlocked my Vsync, so it's free now. It's running as fast as it can. What I need to implement is a clock. SFML has that, so I can do clock. SF clock equal to yeah, I forgot. So documentation. Let's do SFML clock. Okay, so in the tutorial section, you can see handling time. And here they talk about measuring time, which we will do. So we have a clock. We have time, so SF time. Let's do that. I'm gonna put my clock here. This is the main clock, and the clock just measures the amount of time we're moving in. Okay, so I'm gonna start this here. I'm gonna ignore my event loop. So I'm gonna say SF time. I'm gonna call this delta time equal to clock dot get elapsed time. Okay, so this just measures my elapsed time, and then I need to restart my clock. So my clock has to be restarted at the end of my frame, which is here dot restart. Okay, so I'm measuring how long it takes for a frame, completely ignoring my event loop. I don't care about my event loop. So I have a clock. I start measuring how long the clock is taking, or actually at the start of the frame I'm gonna reset my clock, and at the very end of the no. I'm gonna reset the clock here, and yeah, okay. So I restart my clock. I get my elapsed time. No, that's very bad. Okay, so hold on. I need to. If I restart this here, and I get my elapsed time. Essentially, that basically says, hey, reset the clock here, execute all this, and then finally measure my delta time, right? The problem with that is I would like to use my delta time in an update. So if it's at the bottom, that's a problem. But if it was at the top, then I restart my clock, I measure how long this is taking. So this is going to be a problem. Yeah, so see, he's restarting it here. Elapsed. Clock.restart. What does clock.restart give me? Okay, so okay, that makes sense. So this will give me. Okay, this is much better. So now it will restart my clock, but I'm gonna get the time first, restart my clock, and then execute all this. Right, all of this here, and then get the delta time. So in here, I'm gonna do std cout delta time dot as milliseconds. I want it as milliseconds. Std and del. Right. Cout, not count. You are not happy. Why are you not happy? Cout. Oh, I need iostream. Include iostream. Okay, so let's see if this measurement is correct. So, you can see that, well, you can't see because it's going super fast, but these are all 9 milliseconds. Now the last one took way longer, this much. Okay, and the lower my frame rate is, the higher this number should be. Which is it? So it's 66557, right? Okay. Now here's the thing. If I just to verify this is working, if I lock my frame rate, frame rate limit, not frame rate limit, sorry. Vsync, if I enable Vsync to true, I should get 16.6 milliseconds. Okay, which is true. I'm getting 16.6 milliseconds, so you can see 17, 17, 15, 17, 15, 17, right? These are all in milliseconds. Is it millisecond? As microseconds. Jesus Christ, that's why. Okay, let's redo this again. Okay, 60 frames is 16.6 milliseconds, right? What's happening? Why is it white? What did I do? Okay, so now notice my frame rate. It's going to be 60, right? If I pause this for a second, you can see 60, 17, 15, 17, 15, 17, 17, 17, 14, 18, right? Around that tower. Okay, how does that make sense? How is 16 millisecond equal to 60 FPS? This is because think about it. If I do this, I think my tablet died. Okay, I still have a little bit of charge on my tablet. Essentially, if I do 1000 over 1, this is 1000 milliseconds, which is 1 second. Sorry, my apologies. If I say that my frame rate is 60, right? 60 divided by 1000. 1000, this is, so the bottom part is how many milliseconds it is. So I want to check what is 60 frames in 1 second? This is, I'm doing it in milliseconds. If I want to get it in seconds, I just do 1 divide by 1. If I want to do it in milliseconds, I divide by 1,000. So if I do the math here, 60 divided by 1, I get 60, right? If I do 60 divide 1,000, now I'm getting, am I doing the math wrong? Yeah, I'm an idiot. I flipped them. Sorry. Ignore me. I'm an idiot. So sometimes I do that. That's fine. It's fine. So 1,000 divided by 60. This is how many? This is 1 second, right? 1,000 milliseconds, and this is my frame rate, right? So to get how long a single frame takes, is you do 1,000, 1 second, divided by 60 frames. So a single frame takes 16.6666 milliseconds. One frame takes 16 milliseconds to render if you have 60 frames per second. So 16, if you multiply this by 60, so 16 milliseconds, one frame. So if I want to calculate how long it'll take to render 60 frames, 16.6 milliseconds multiplied by 60, I get 1,000 seconds, right? So this basically, if I do 1,000 divided by 60, I'm just calculating. I'm basically essentially saying my frame rate is 60 right now, right? And I want and I get 60 FPS per second. I would like to find out how long one frame takes. So you divide these two and you get 16.666 milliseconds. That's per frame. So the time it takes to render a single frame is 16.66 milliseconds if you have 60 FPS. What if you have 30 FPS? Well, you take 1,000, divide by 30 frames, and now it takes 33.333 milliseconds to render one frame. So you can see that's increased. Okay? And that's going to be our delta time. So now here I'm checking. I'm seeing if I'm calculating delta time correctly. If I am calculating delta time correctly, then that means whenever I print delta time and I lock my frame rate to 60 by enabling Vsync, that means that should continuously get this number around close to 16, right? Because 16 milliseconds. So if I pause this, you can see I'm getting around that number. 15, 18, 15, 18, 16, 15, 18, 15, right? And so on and so forth. So I know that I'm calculating this correctly. Now, if I put this at the very top, over here, now I'm including my loop. Or I was always including my loop, actually. Right? But I get that time from top. So again, I'm getting 18, 14, 18, 14. You know, close enough. I'll keep it at the top. It's fine. So that's my delta time. Now, here's the thing. So now I'm going to pass delta time here. I'm going to pass delta time here. Which means in update, now we ask for float delta time. And skeleton, we're going to ask for a float delta time. Right? We need delta time to be passed in here. And these are flipped. What is delta time? Delta time as milliseconds. This returns milliseconds. As milliseconds, right? So actually what I'm going to do is I'm going to do float delta time to this. This will be delta time counter or delta time timer. Sure. Delta time timer, delta time timer. So the reason I'm doing this, why I didn't do that? So I'm storing it in a variable, then using it rather than doing this, is because I'm afraid that if I call this function, it's going to give me a different value for skeleton and player, because skeleton execute first, so I might get a slightly different values for skeleton than player. Where if I store it in delta time here, I just store it once and then I can use it multiple times. I'm guaranteed that this will have the same value because I executed this line over here, right? So delta time is going to have the exact same value throughout my program. It's only gonna change later on this line, right? But I'm afraid if I just do this, then this will be slightly different because I'm calling this function than this, or I'm calling this function again. I'm not sure. I'm just, saying maybe that would happen. So this is a little bit better. Okay, so now here's the thing. Now, when I set my position, I'm taking the previous position, adding to it the direction, multiplying it by speed. I need to create my speed variable, multiplying it by delta time for all of them. Okay, and even my bullet, when I move my bullet, so here, here bullet speed. I already have bullet speed. Just need to multiply by delta time. Okay, now I need to make the player speed. So float player speed equal to 5.0 again. Do the same thing. Or let's do 2.0. It's gonna be player speed, player speed, player speed, player speed. Okay, and now what I'm gonna do is turn off Vsync. Now notice how the speed of the bullets and the speed of the player are gonna be constant no matter what my frame rate is. Okay, so I'm gonna move. Okay. There you go. No matter what my frame rate is, it's always the same. At the very start, it was very jittery though. At least for me, it was. I don't know why it was super jittery. Like, look how. I don't know what's going on with that. But then when I started firing, my frame rate dropped a little bit. I think it's a little bit better to just set frame rate limit, and I'm gonna set my frame rate limit to 240 frames. So that's kind of the ceiling, the limit. It can't go above 240. Right, and I think this will have a more constant result. There you go. So now, oh, my PC lagged a little bit. So now, if I shoot, no matter what my frame rate is, so you see it's gonna drop now from 240, 180, 190, 170, 160. Right, no matter what my frame rate is, I have a constant speed. I have constant speed over here, which is awesome. Well, I don't know why. I can just hold my mouse. And look, my frame rate is dropping a lot, like a lot. I'm at 70 now. It's gonna keep dropping, and I still have the same speed because I'm multiplying by delta time. Delta time is increasing the more my frame rate decreases, which is cool. Right, now I'm gonna change the experiment a little bit, right, and remove delta time. move delta time, delta time, delta time, delta time, and delta time from here. And let's see what happens. Now you'll see my game. So my guy is moving. Gonna shoot bullets. Notice how slower it's getting. Like, look at my player. He's taking much longer to reach the edge when I started the game. Look, my frame rate. Here, let's do an experiment. Let's count how long it's taken him to move from right to left. 1, 2, 3, 4, 5. Took 5 seconds. Okay, now let's reduce my frame rate, like tank my frame rate. Tank it, tank it, tank it. Let's get to like 100 frames. Let's start counting. 1, 2, 3, 4, 5, 6, 7, 8. Took 8 seconds now because my frame rate dropped substantially. Alright, let's do this again. Let's start counting from around 75 FPS. But remember, it was taking 5 seconds at 240 frames per second. Let's count now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. See how slow it is? Because I'm not, like, my movement is now tied to my frame rate. But if I multiply by delta time, right? Delta time is gonna increase the lower my frame rate is. So let's do the same experiment. Let's figure out let's count how long it takes him to move to the right. 1, around 2, right? Around 2. Okay, let's actually reduce the player speed a little bit. Let's do 1 here. Okay, so let's check. 1, 2, 3, around 3 seconds. Okay, I'm gonna tank my frame rate to 70 FPS, and then I'm gonna see, is it also the same? Is it still 2, or is it gonna be a lot more? Come on. I'm gonna reach to 70 frames and then move. Remember, it took like 3 seconds. When we were at 240 frames per second, it took 3 seconds. Okay, let's count. 1, 2, 3. Same amount of time. No matter what. No matter what my frame rate is. Let's do it again. 1, 2, 3. 3 seconds. Because we're multiplying by time delta. So now, our movement is not tied to our frame rate. Our frame rate can tank, and our movement will still be good. Cool. And again, the way we did that is essentially here. We have a clock. We created our clock. We restarted the clock at the beginning of our loop. And then we calculated the time, the delta time. Once we calculated our delta time, obviously at the very beginning, the first time we do this, it's going to be 0. But then I go through my event loop. I go through all of this. This is 1 frame. I'm done with 1 frame. I restart my clock. And then I get this. I do not like the fact that I restart my clock. So, I'm going to restart my clock. I'm going to take this measurement at the very end. So, hold on. This is a little bit wonky. Let's do time to delta time here. Because I don't like this fact. Like, see what I'm doing? I'm restarting the clock. I'm getting time delta time. I mean, see, restart says, restart the clock. This function puts the timer counter back to 0. It also returns the time elapsed since the clock was started. So this is fine. Like, it's going to give me the time before it restarts. Okay, so technically this is fine. Okay, so let me explain this again. Sorry, let me do this one more time. Okay, so what am I doing here is I start my frame, I start my loop. I restart my clock to 0. Okay, this is 0, this is all 0. I go through my loop. I go through my first frame. First frame, let's say it took 60 milliseconds. So I restart the clock, but before I restart the clock to 0, I store 60 in here, right? Now 60 is being used here, right? I'm taking 60 and storing it in deltaTime, okay? And then restarting the clock to 0. So now the clock is 0, okay? deltaTime, I'm taking deltaTime here, passing it. I said the previous frame took 60 frames. It took 60 milliseconds. I passed the 60 milliseconds, and I go render my second frame. My second frame, go here, and let's say my second frame also, let's say it took 50 milliseconds. So I store 50 in this variable, deltaTime timer. I restart my clock to 0, and now the 50 is stored in deltaTime, and I can use it here. Now that I think about it, I really don't need this. I can just pass this over here, right? Because I know that this value, deltaTime timer, will not be changed until this line comes through. So there's no difference between those two. There's not going to be a slight difference, right? Like I previously said. But this is kind of nicer to have just a variable over here. It's shorter. Other than that, everything is fine. Start my loop. I start my loop. I restart the clock. I calculate deltaTime, which is 0. So these are the first frame, 0. I render a single frame. Next frame, I store the deltaTime here. And let's say now I'm basically storing this deltaTime timer is storing how long it took for the previous frame to render. So let's say 60. So this variable is now storing 60. I restart my clock. I get 16 milliseconds. I store it in this variable and I pass it. I render my third frame and I restart my clock. Before I restart my clock, I get how long it took to render the previous frame. Let's say this time it took 40 milliseconds. I store 40 milliseconds in deltaTime. I pass 40. I render my fourth frame. I restart my clock. I restart my clock, but before I restart it, I store the previous frame, how long it took. Let's say this time is 30 milliseconds. So 30 milliseconds back stored in deltaTime, I passed it, and so on and so forth. And I keep doing this over and over and over and over. Right? That's the entire idea. Right? Here I'm just setting the frame limit to 240. I don't want my my game to go above 240, right? Or what, 360 now? The fastest refresh rate monitor is 360. I'll just set it to 360. Right? And my clock is just my clock. I restart my clock when I need to restart my clock. Right? That's it. Now our code is not tied to any frame rate. It is independent of my frame rate, which is awesome. All right, that's it. That's all I want to cover for this session, and I'm gonna call it. Thank you guys for watching, and please like and subscribe. Woo! And yeah, I'll see you guys tomorrow. Take care.